Parts of an atom. You can take notes in your journal, just looking at where the parts of an atom are and what an atom is like. This is a great video. If you want to watch it, you can Google Ed Ted size of an atom and it will come up, or you can use the QR code or a link if it's available to you. So atoms are made of three primary things. They're made of protons, neutrons, and electrons. So the protons and the neutrons, they are located in the center of the atom called the nucleus. And then way outside of the center, you'll find these small particles called electrons, and they would be way outside the nucleus. What about the mass of each of those items? So I'm just going to abbreviate protons, P+, neutrons, and electrons, E-. It turns out that the mass of a proton is equal to 1 atomic mass unit. You can Google why that is. It's based on the gram, and I explain it in class, but I think for the purpose of online it would be a little much. Neutrons also have the same exact mass, and electrons, they do have a mass, but it's so small we just don't count it. You can imagine like a semi-truck pulling up to a weigh station, and the semi-truck isn't going to worry about like dust particles on it. The dust particles are too small to count towards the mass, so we just call it 0. What about charge? There are two kinds of electrical charges, positive and negative. And a third, I guess, would be neutral, just meaning no charge. So protons, they have a positive charge. Each proton has a +1 charge. So if you had, for example, 2 protons, it would have a +2 charge. Neutrons, they don't have a charge. They're neutral, so no charge. And electrons, they have a minus charge. So again, just like protons, if you happen to have 2 electrons, they would have a -2 charge. What about the identity of the atom? So if you had a periodic table has different boxes on the periodic table, and each box represents an atom. The very top number tells you the number of protons, and that turns out to be the identification of the atom. So for example, if an atom had 4 protons and 5 neutrons and 4 electrons, well, to find out what atom that is, all you would do is go to the periodic table, use the number of protons, and find the top number here, and whatever atom that is the identity of the atom. And in this case, so here's a periodic table, I'm not sure how well you can see it. The number 4 at the top is beryllium, so this atom would be beryllium. To draw an atom, it's going to be a simplistic drawing to begin with. You have the protons all in the center, so I'm just going to put P+. It turns out some atoms will have 10, 20, 30, 40, 50 protons even. And as you already know, protons, if you had positive charges, they want to push away. So you would think the center of the atom would explode. But it turns out there are these things called neutrons, and they're like the glue that holds them together. So this center part, we have a name for it, it's called the nucleus. And then outside, far away from the center of the atom, are these little tiny particles called electrons, and they roam around the outside. They don't go in an exact circle, but for now we'll draw it as a circle. They move at really fast speeds around the center of the atom, but long ways away. An analogy would be if the nucleus were the size of a marble, where would the closest electron be? Imagine a giant football field, and if you were at the furthest part of the stadium, the nosebleed seats, or the way out there, that would be the first electron, and this little marble, which represents the nucleus, would be sitting like on the 50-yard line. Okay? So what is between here and here? Interestingly enough, mostly nothing. So an atom is actually mostly empty space with a very dense center called the nucleus that has protons and neutrons. And way outside, you'll find the electrons moving around. So we did some, let me just go back real quick. If you were in class, we did all these activities with whiteboards potentially to figure out different ways we could put atoms together, and you figured out charge and mass and stuff like that. So you're not going to be able to do that from here, but let's just go over a few scenarios. So I got some questions here. What would be the mass of each of these atoms that you see on the screen? It'd be a good time to pause and see if you can figure it out. Once you have an answer, or if you need more help, you can keep it going and I'll show you how to do it. So these are like the models we set up in class and of atoms, and it's just a visual there to help you. So it turns out that mass, if you remember from what we talked about, each proton has a mass of 1, each neutron a mass of 1, and each electron pretty much a mass of 0. So in terms of calculating mass, these don't matter. So really all you have to do is add protons and neutrons. So this would have a mass of 10 atomic mass units. So you just add protons and neutrons to get mass. This one would also be 10 atomic mass units, and this one right here would be 15 atomic mass units. So you get the mass, you add the protons and neutrons. Oh, what about charge? Well, let's go real quick over what each thing is. This would be a good time to pause if you think you know how to do it, and then you can check your answer. Welcome back. With charge, the neutrons don't matter. They don't have a charge. So I'm just going to get rid of that number. It's not going to matter. Remember that every proton has a plus charge, and every electron has a minus charge. So this atom here has 5 plus charges and 5 minus charges. 5 minus 5 is equal to 0. So this atom here is neutral. What about this atom? Well, it has 6 plus charges and 5 minus charges. 6 minus 5 is equal to 1, positive 1. So this atom is a plus 1 charge. And the last atom over here would have 7 plus charges, so plus 7, and minus 9 for electrons. So you end up with a negative 2 charge overall on that atom. And finally, what about the identity? I put a small clipping of a periodic table here, or you can use your own. You can pause the video again and see if you can identify each of those atoms. Welcome back. Well, it turns out the identity only matters the protons. So we don't even need to worry about those when trying to find the identity. So let's see here. The first one is 5 protons, and the top number on your periodic table is the number of protons. So this atom is boron. The next one, 6 protons. Top number is the number of protons, which means it's a carbon atom. And 7 protons is a nitrogen atom. That's our cue to stop. So this is an introduction to the parts of an atom. Thank you for watching.